Hello guys, welcome back to another episode of Codergirl.py. My name's Serenity, aka Codergirl. This is my friend Scooter. Today, I'm going to introduce you to operators using Python. Hope you enjoy. Alright, so if I open up my IDE, you'll notice I have one new folder, operators. In it, I have 4 files, operators.py, operators.txt, operators1.py, and operators1.txt. Let's open up operators.txt first. The first thing you'll notice is that this file doesn't actually contain any Python code. Rather, it just contains some text. Second thing you'll probably notice is that this file ends with the extension .txt instead of .py. This is because I am writing in a text file, so I'll need the extension .txt to give a hint to the computer. Perfect. When you program, you'll want to tell the computer to do a task: addition, multiplication, division, etc. For example, if you are making an online banking website, you want to tell the computer or you want to subtract any withdrawals from the actual bank account. In programming, we use operators to do this. In operators.txt, I have a list of all of the arithmetic operators available to us. Arithmetic operators return a number and work just like they would in math. You can see I have 4 plus 2 is equal to 6, 7 minus 5 is equal to 2, and 8 times 9 is equal to 72, etc. You'll probably notice that I'm using 2 equal signs here, whereas if I were to declare a variable, my num, and set it to 2, I'd only use 1 equal sign. This is because in Python, 1 equal sign assigns a value to something, and 2 equal signs actually represents 2 things being equal. So when my num equals 2, I want to assign the integer 2 to the variable my num, so I'd use 1 equal sign. However, in 4 plus 2 equals 6, I don't want to assign 6 to 4 plus 2. I want to show that 4 plus 2 is equal to 6, so I use 2 equal signs. It does take some getting used to. So in operators.txt, like I said, I have a list of all the arithmetic operators. And again, they work just like a calculator would. You'll probably recognize these a lot from math: addition, subtraction, multiplication, division, and exponent. However, we have 2 new operators that you may or may not have seen before: the modulus or modulo, and then floor division. The modulus returns the remainder of a division operation. For example, when I use the modulus with 29 and 7 goes into 29 evenly 4 times with a remainder of 1, so our result is 1. Floor division divides and then rounds down to the nearest whole number. So when I use floor division with 8 and 3, 8 divided by 3 is actually 2.6 repeated. However, since I'm using floor division, our result is 2, since we round down to the nearest whole number. Perfect. So far, I've been using integers in all of this. However, we can also use floats in our operations. I can change this, for example, to 4.3 plus 2.5. So now my result will be 6.8. And rather than just have this result hanging midair, we can assign it to a variable. For example, I can write my operation is equal to 4 plus 2. Notice I'm using 1 equal sign here because I want to assign 4 plus 2 to the variable my operation. Rather than literally store 4 plus 2 in my variable, the computer will evaluate what 4 plus 2 is equal to and store that in the variable my operation. 4 plus 2 is 6, so the computer will store our result, 6, in the variable my operation. So now my operation is equal to 6. And I can also use variables in these operations themselves. For example, I can write num1 is equal to 4, num2 is equal to 2, and then I can write my operation is equal to num1 plus num2. A variable's name acts as a placeholder for the variable's value. So this is the exact same as writing my operation equals 4 plus 2. The only difference is that in the first line of code, my operation equals num1 plus num2, I am not explicitly saying the variable's value. I'm using the variable name instead. In both cases, the computer will evaluate what our operation equals. Since our result is 6, it stores the integer 6 in our variable my operation. Perfect. These are all arithmetic operators, like I said, but those aren't the only operators available to us. We also have comparison operators, which are extremely useful. So let's head over to operators1.txt and show you what I mean. Again, you'll notice that this contains text instead of actual Python code. And it also ends the extension .txt. This is because, again, we're working in a text file, so I need the extension .txt to give a hint to the computer. In comparison operators, when I use them in an operation, the computer will evaluate whether my operation is true or false. So, for example, next to my greater than, I have the example 6 is greater than 5. The computer will evaluate if 6 is actually greater than 5. Since this is the case, the computer will store a Boolean, the result will be a Boolean true. However, in my example, 7 is less than 4. When the computer evaluates if this is the case, if 7 is actually less than 4, it finds out that 7 is actually greater than 4. So our result is the Boolean false. And you'll probably recognize a lot of these from math as well. We have greater than, less than, greater than or equal to, and less than or equal to. But we also have equal to and not equal to. Notice in the equal to operation, I'm also using two equal signs. Just like arithmetic operators, I can use floats with comparison operators. So I can write 6.2 is greater than 5.3. The computer evaluates if this is the case. Since 6.2 is actually greater than 5.3, the computer returns true. And again, just like arithmetic operators, we can store the result of a comparison operation in a variable. For example, I can write my operation equals 6 is greater than 5. Rather than literally store 6 is greater than 5 in my variable, my operation, the computer will evaluate if this expression, 6 is greater than 5, is true or not. Since it is true, since 6 is actually greater than 5, our result is the Boolean true. So it stores the Boolean true in the variable my operation. And again, just like arithmetic operators, we can use variables in the operations themselves. So I could write num1 equals 6, num2 equals 5, and then I could write my operation equals num1 is greater than num2. Again, variable name, it acts as a placeholder for the variable's value, so this is the exact same as writing my operation is equal to 6 is greater than 5. In my first line of code, I'm using the variable name instead of the actual value. So now let's see these operators in action. Let's head over to operators.py. In it, I have a ton of print statements. Just like you can store the result of an operation in a variable, you can also print it. Take my first print statement, print 5 plus 3. Rather than literally print 5 plus 3, the computer will evaluate what 5 plus 3 is equal to. 5 plus 3 is 8, so the computer will output 8. And in our last print statement, we have print 12 is greater than or equal to 4. The computer will evaluate if this is the case. Since 12 is greater than 4, this will output true. And when I hit the run button, you can see we do get the expected outputs. However, since we just have so many print statements, I can drag this run panel up here. So now we can see all of our outputs at once. Perfect. So far, I've been using variables, integers, and floats in these operations. However, we can also use strings and booleans. The only difference is that some of the operators act a little strangely. Let's head over to operators1.py and show you what I mean. In operators1.py, I have some print statements with some funky operations inside. Let's go through it line by line. My first print statement is print hello plus world. When you use the plus sign with two strings, the computer combines them into just one string. So hello plus world, the computer will combine hello and world into just one string, hello world. Our second print statement is print hello times 5. When you multiply a string by a number, the computer replicates the string that many times. So hello times 5, the computer will replicate hello 5 times. So our result is one string that is hello, 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 hello. Perfect. Next up, we have print true plus 1. In Python, true stands, of course, for true, but it also stands for the number 1. Likewise, the Boolean false stands for false, but it also stands for the number 0. So in print true plus 1, since true stands for 1, 1 plus 1 is 2, this will output 2. And in our next print statement, print false minus 1. False also stands for 0. 0 minus 1 is negative 1, so this will output negative 1. And our fifth print statement is print A is less than B. When you use the less than or equal to sign with two strings, the computer will check if the first string comes before the second string in alphabetical order. In this case, it will check if A comes before B in alphabetical order. Since this is the case, the computer will output true. However, if I change this to greater than or equal to, the computer will now check if the first string comes after the second string in the alphabet. So in this case, it'll check if A comes after B in the alphabet. Since that is no longer the case, this will now output false. And our last print statement is print hello equals hello. You'll notice that I'm using the equals to operator, which is a comparison operator. When you use the equals to operator with two strings, the computer checks to see if the first string is exactly identical to the second string. So in this case, it will check if our first string, hello, is exactly identical to our second string, hello. Since this is the case, this will output true. However, if I changed one of these strings to all caps, so if I change this, the second hello, to all caps, these strings are no longer exactly identical. So this will now output false. And sure enough, when I hit the run button, I get all of the expected outputs. Perfect. Thank you so much for watching. I hope you enjoyed this video. If you did, please leave a like and subscribe, and I will catch you guys later. This is Codergirl.py signing out.